Ever seen a comment on social media by a blind person and thought, well, just how did they manage to post that exactly? Or maybe you've walked past a blind person in the street and you've heard something like this and wondered what exactly is going on there. Let me give you some insight. In P2, of course, we learn about the idea of accessibility, or universal access, the idea that we should be making computer systems accessible to all manner of people, including those with disabilities. And I think the most important computer design principle here, when making software accessible to blind and visually impaired people specifically, is know thy user. Making software accessible for the blind and visually impaired can sound like a very daunting task if you don't understand how blind people use computers. And indeed, sometimes making software accessible can be quite a daunting task, especially if it's visual. But thankfully, operating systems and graphical toolkits already provide a lot of features and have done a lot of the work for you to make the apps and programs you create somewhat accessible out of the box. With that said, although they might be mostly accessible out of the box, a little bit of planning and code on your part can really help improve the experience. People with no or low vision can use a lot of different accessibility aids in order to get around their computers and devices. The first one is magnification. That's the idea that you are zooming in and viewing parts of the screen at a larger size. This is employed by people who have some vision, other people who don't have any vision at all, or people who don't have much usable vision, like me, don't tend to do this. But basically every operating system on the planet provides this out of the box, and you can just enable it in accessibility settings. And they provide a whole host of other features as well, such as flashing the entire screen if you get a notification that pops up outside the area you're zoomed into. You as a software developer usually don't have to do too much to allow zoom to work. It is usually done for you by the operating system. However, if you work with images in your program, you may want to consider adding zoom controls so that anybody, not just people with low sight, can zoom in and view the pictures in more detail. But there are some problems with magnification, namely, because it makes everything on the screen bigger, you can't fit as much on the screen, and thus you have to pan around the screen with the cursor to see the entirety of whatever you're looking at. One alternative is, instead of making the entire screen bigger, we just make the text bigger. That way images and other content stays exactly the same size, but the text is easier to read for people who are partially sighted. Almost every web browser offers both zoom and text size adjustment these days, and when designing things like web pages in particular, you should be mindful that somebody's font size may have been changed from the page's default value, and make sure that your page still looks okay when this happens. There are a whole host of other so-called display accommodations. I could go through a massive list of them. One of the most important ones for a lot of people is inverted colors or high contrast, where instead of having black text on a white background, you will have white text on a black background. Now, I want to say here, this is different to dark mode. Dark mode in a lot of modern operating systems is a lot easier on the eyes. However, it doesn't have nearly as high a contrast as the inverted colors mode, as the background normally isn't pure black. All major operating systems implement this in one way or another. On macOS, it's called inverted colors, and I have set up a keyboard shortcut to toggle it. On Linux, it is a theme that you can select. And on Windows, you can press Alt-Shift print screen on any Windows box to automatically enable high contrast. Again, most of the time, if you're using the default settings in a graphical toolkit, you do not need to implement this yourself. The operating system will do it for you. However, if you are drawing custom controls or anything like that, you will want to check if the user is in high contrast mode and draw your controls appropriately. There is also so-called Smart Invert, where the text and most of the controls are inverted, but images stay the same so that you can view them normally. Many operating systems and apps provide a reduce motion setting, so you can get rid of needless animations that may confuse a partially sighted user and get in the way. Reduce motion usually turns those sliding animations and things like that into fades. And of course, some people are colorblind, so a lot of operating systems and applications provide a differentiate without color setting, as it's called in macOS, which means that color is not used to distinguish between different items on the screen. Instead, maybe the foreground and background will be inverted, or some higher contrast, easier to understand color scheme will be used. Again, if you're using the native graphical toolkit for your platform, or even if you're using another one that has accessibility features built in. They will quite often do these things for you. On the web, you can also detect these features. However, if you're drawing your own controls, or let's say you're styling your own web page with CSS, you will want to make sure that you take these things into account. Modern CSS3 does provide things like media queries to ascertain whether things like reduced motion are enabled and adjust your websites accordingly. Now we come on to screen readers, and these are perhaps the hardest to explain and most complicated assistive technology. They can be extremely complicated and have a lot of features. However, you shouldn't be frightened by them. They are actually quite easy to start to learn how to use in order to test your own programs and websites for accessibility features, and I'll demo that now. So in order to test an app or a website with a screen reader, you're going to need an app or a website to test, and we're going to be using blindcomputing.org, which is a website that I used to run and still maintain, although it hasn't been updated in quite a while now, and it contains accessibility information to teach blind and visually impaired people how to use various pieces of assistive technologies, and you're going to need a screen reader, and for that we're going to use NVDA. So without further ado, let's start it up.
Desktop list. File hour 1 of 2. Home blind computing document. Banner landmark. Navigation landmark. Navigation landmark.
Wait a minute. What on earth does that say? Yeah, so screen reader users tend to use their text-to-speech engines at a very fast rate in order to consume as much information as quickly as possible, and over the years you turn your speech rate up and you get used to it. But for the sake of all of your sanity, I will turn this down now so you can actually understand what it's saying. And to fix that, all we have to do is delve into the NVDA settings menu and go to the speech tab, and we can change the rate right here to something a lot more easy to understand.
0.
That might be a little too slow.
20.
Something like
10.
10 might work quite well for this demonstration.
Cancel button. OK, space. Home blind computing document. Link operating systems. Link software.
And hopefully that's a lot easier to understand. So, getting on with the demonstration. The main way that screen reader users use their computer is with the Tab key, which is the key above the caps lock key, the Shift key, and the arrow keys. If you press Tab,
Downloads link. Blog link. Main landmark brailleinotersers.info link view. Contributing page link.
you navigate forwards through the items on the page, and if you press Shift Tab,
brailleinotersers. Bannerland. Downloads link. Software link. Operating.
You go backwards. The arrow keys are used when reading documents such as web pages, so for example I can press the down arrow here.
Link software. Link downloads. Link blog.
And it will read those same links, but if I scroll down a bit.
Broader scope of topics that are not necessarily related to the Braille note. Heading level 2 How to contribute. Please see the link contributing page for more information.
And I think it's fairly obvious that if I press left and right arrow, it starts reading out the characters, and obviously
heading level
up arrow
2
goes backwards. Screen reader users do not very often use a mouse. Most of us own one, but as you can see on my desk, I don't have one currently set up and I don't normally use it. What I use instead are lots and lots of keyboard shortcuts. Some of these are provided by the operating system itself. For example, I can press the Windows key on the keyboard to open the Start menu and open something like Notepad.
Notepad. Text.
I can press Alt F to open the File menu and scroll through the items. And I can press Alt F4 to close the window. Others are provided by the screen reader, and most of the time they are customizable, such as being able to press Ctrl to pause speech like this.
Out of link. Link download. Link block.
Or Shift
Mainland.
to pause and resume.
And mark heading level 2 What is blind
the speech. Or being able to press certain keys to navigate through web pages faster. For example, if I press H.
Main landmark What is blind computing. How to contribute heading level 2. Note on browser support heading level 2. Latest news heading level 2.
I scroll through the headings on the page, and if I press Shift H.
Note on browser support. How to contribute. What is.
It scrolls backwards. As I said, screen readers are often very, very customizable. You can decide exactly what is spoken, when it's spoken, how it's spoken, and how your keyboard presses affect exactly what the screen reader or the OS does. NVDA not only has this dialog to let you change all sorts of settings regarding different parts of the screen reader, but it also has
Input
the
gestures.
input gestures
Input
dialog,
gestures.
which
Vision
lets you
collapse.
change
Expand.
even
Touch.
more
Expand.
settings.
To
These
expand.
are all
Text.
the different
Expand.
keyboard
Expand.
shortcuts that you can use
Expanded.
to do various things with the screen reader. They also often have add-ons to add additional functionality, for example, making apps that aren't normally accessible more accessible, or including or modifying other functionality in the screen reader. You can also connect screen readers to various pieces of assistive equipment, such as a braille display, like this Braille Note Apex BT32, which enables you to read what is on your computer on a refreshable braille display. As a side note, these things aren't cheap. When I got this thing something like 13 years ago, it was £7,000 and I had to get a charity to fund it for me. These days they are at least a little bit cheaper. You can still buy this model. It is only £3,000 now, because that's a massive discount and still massively expensive. The newer models cost more than that. I think the Touch Plus, which is the newest version, costs something like £5,200. As you can see, there are a lot of screen readers out there for different platforms. There is possibly the most on Windows, as really this was the first mainstream platform that blind people could actually use way back when. But there are lots of different screen readers out there. Apple has their own called VoiceOver, which is available on all their devices. The GNOME project has the Orca screen reader for Linux and other free desktops. Google has pushed TalkBack as their screen reader for Android, and there's also Commentary screen reader and a couple of other options that I didn't mention on this slide because they're not really used anymore. But the screen reader space continues to evolve, and there are always lots of different options. One of, if not the most popular screen reader in the blind community is NVDA, Non-Visual Desktop Access, which is a free and open source screen reader for Windows. That is my preferred screen reader of choice on Windows. The text-to-speech of a screen reader reads 3 important properties of each control it reads, and that is the name of the control itself, i.e. what the control is labelled as, the role of the control, which describes what kind of control it is. Is it a checkbox? Is it an editable text field? Is it a combo box containing selectable items? Is it a list view? Is it a link on a web page? And the state of that control. For example, is a checkbox checked? What does a text field have written inside it? Is a link visited? Things like that. Putting that all together, we get
email address or phone number edit selected you at example.com. Password edit protected selected 8 bullet. Login button. Forgotten your password. Keep me signed in checkbox not checked. Checked. Keep me signed in checkbox checked.
As I've said, most screen reader users use the keyboard for navigation, and for this reason, if you want to make your apps accessible, one of the most important things you need to focus on is keyboard navigability and accessibility. Can you do everything that you would normally do with a mouse in your application with just the keyboard? If you can, that significantly increases your chances of your app being accessible, although it isn't the be-all and end-all of accessibility, as we'll see. So, in order to more easily show you how to make apps accessible, I have created an example program. So, for a bit of variety, I'll do this part on Linux. The application I have created is very simple. It's a simple logger application. So you type in a date, we'll leave it at New Year's Day 2023, and we will type a log message, New Year's Day, and if we press log, you can see it appears up here, and we can do other ones. So for example, if I set this to the 21st, I can type in my 20th birthday and log that, and it shows up here, and we can skip through both backwards and forwards, which obviously looks the same in this application, through the different log entries up here. And the code for this application is on screen right now, and you will also be provided with this should you wish to peruse it. Step 1 when making your app accessible is to test it with a screen reader. There is almost certainly one built into your platform. On Windows there is Windows Narrator, on macOS there is VoiceOver, on Linux there is Orca, or you can always download a free screen reader, for example NVDA on Windows, which a lot of people consider to be the gold standard for testing accessibility of apps on Windows. Above anything, and I want you to remember this, someone in the blind community is always happy to help. If you want to make your software more accessible, we will be very happy to help you do so because it benefits us. So you should get in contact with us on social media or in any way that you see fit, and see if any of us would like to test the accessibility of your application and help you improve it. With the application running and the screen reader on, the first problem I notice is that other than the log button here, basically everything else is unlabeled if I tab through them.
Push button, one text, one text, 2023 text, 2023 text.
To fix this problem, we should add accessible labels to controls. The label is announced by screen readers instead of the usual name of the control. For example, instead of the screen reader announcing less than when I'm on the previous entry button, it could announce previous entry if I set the accessible label to that. These labels should be as descriptive as possible using as few words as possible, particularly for buttons, for example, previous entry or next entry. And to do that in Java, we first obtain an accessible context object from the widget we want to label, using the getAccessibleContext method, and then on that context we call the setAccessibleName method, passing in what we want the label to be. I am also setting the mnemonic here, and that is a keyboard shortcut, so you can press Alt-P for the previous button and Alt-N for the next button, which will improve accessibility for keyboard users. And you don't need to do this to every control. For example, the log button has the word log written on it, and that's what the screen reader will already announce, so you don't need to give it another accessibility label. In this app, we have a label that currently screen reader users cannot access because it is not keyboard focusable. And unfortunately, in our case, that label just so happens to be the label that has the text containing the current log entry, so we should probably fix that. Fortunately, this is very easy to fix. All we have to do is call the setFocusable method on the control and pass in true. Although we don't have any in this app, making images accessible is also very important. Now, you don't have to do this with absolutely every image. For example, you don't have to describe what a save icon looks like. You don't have to describe that it's a floppy disk. You only have to describe that that is the save button. But if you have an image of, say, a landscape, or maybe an image describing how to use your software on the help page, or anything like that, you should describe what is in the image using the image's alt text attribute if your graphical toolkit supports it, or otherwise just put a caption below. Writing alt text is a little bit of an art, and there are many guides online to show you how, and I have linked one in these slides associated with this video which you can download. But above all, the important thing to remember is any description is better than none at all. Another accessibility issue with this app is, well, even if we label these buttons, it's quite hard to understand what some of these controls do. For example, the date fields. Day, month, and year. I only know that that is day, month, and year because I wrote this application. Maybe it's quite easy to understand that this is the year, but if it's set to a date that isn't the current year, that also might be quite difficult. It's hard to understand what these controls do because the labels that, well, label them aren't associated with the controls, and so when the screen reader user tabs through the controls, their names aren't announced. You can solve this problem in almost every graphical toolkit by associating the label with the control. And you do that in Java by simply calling the setLabel4 method on the label control and passing in a reference to the control that this label is actually labeling. When the screen reader user tabs to this control now, then normally it would read the associated label out. However, there seems to be a bug on Linux right now. I don't know whether this is an issue with the Java runtime itself or with the Orca screen reader, but when I tab to it at the minute, it still only says 1/1/2020. However, it does at least announce the date panel label and the message label, the fact that that's labeled as current entry, and I can see this label here as well. Accessibility bugs, especially on Linux, aren't that uncommon, and to be honest, on any platform, they are not uncommon at all. Screen reader users are very used to working around issues like this. Not that they necessarily should have to be. I obviously think we should be making our programs as accessible as possible, but over the years, you do get used to things like this not working, and you learn to use other features of the screen reader. So that's just a quick overview of how blind people use computers and technology, and how you can make your programs accessible. And if you have any questions, don't hesitate to get in touch with me. I'll put my email address on the screen right now. And I have also provided links to a bunch of resources on the end slide of the presentation.